All right, folks, and I'd like to take a moment to talk to you about the second derivative test for local extrema. It's super easy. If my derivative equals 0 at a spot and my second derivative is negative at that spot, what you should recognize here is if I have a horizontal tangent, but it's concave down, then that would mean he's frowning at that spot through there. And so obviously that would refer to a local max at x equals c. Okay. And then obviously for the other one, if my first derivative is equal to 0, but my second derivative is positive at that point, that would mean I would have a local min because I would be smiling through that point. So we're going to just do an example here using the second derivative test. It says find the local extreme values of this function. Let's find our first derivative. That would be 3x squared minus 6. And then my second derivative would just be 6x. Kept this nice and simple for us. My first derivative is equal to 0. When I set this equal to 0, 3x squared minus 6 is equal to 0. 3x squared is equal to 6. X squared is equal to 2. So x is equal to plus or minus the square root of 2. Okay, those are the two places that I have critical points. Okay, those are going to be potential max or mins. I'll find out if they're max or mins simply by putting them back into my second derivative. The second derivative of the negative square root of 2 is going to result, I'm sorry here, is, oopsie. The second derivative of negative square root of 2 is going to be less than 0. So that would mean that it would be frowning. And so in that case, it's going to look something like this. So this would be a local max. Okay, and then if I find the second derivative of the square root of 2, that's going to be greater than 0. And in that case, it would be smiling, so he would be a local min. And I'm not going to take the time to actually find those values. I just wanted to run through that with you quickly. Have a great day, everyone.